Welcome to Hoffman Tactical. In today's 3D2A development live stream, I have on a very interesting guest, Yukon, and you guys probably know him from Twitter. He's also got a YouTube page. He does some very interesting work and has some very interesting ideas in relation to UAVs or drones, as you guys probably more commonly know them. And he has a lot of interesting stuff to talk about, and that's what we're going to be discussing today. So why don't you guys let me know if the stream is coming through clearly, if the audio sounds good, and just looking up here, let's just remove that. It looks like we might have had an issue with Rumble, but that's okay. We are mainly on Odyssey and YouTube right now. So so I'm going to bring on Yukon, and we're going to start talking about it. Hey, Yukon, how's it going?
Hey everyone, I'm Yukon. I run a project called Canine Defense Technologies, and hey Tim, it's great to be here. I'm here to talk about the stuff I do, which is drones, and right now I'm also working on things like augmented reality and testing other kinds of technologies. And I'm excited to get into this and start talking. So.
Absolutely. Yeah. There's a lot of focus, I do 3D printed firearms, a lot of focus on firearms, obviously. But I think that more advanced technologies and stuff are extremely important in today's combat environment, or however you want to look at it, conflict environment. And I think that should be a much bigger focus of the
accessible
do-it-yourself weapons systems ecosystem, if you want to call it that.
And, for sure.
That's why I found what you're doing really interesting. It's something I've kind of dabbled with in the past, but I've never really gotten into it. I don't know that much about it. So I think that you'll be able to bring a lot to the table here that we can discuss that should be really interesting, and kind of talk about what the future holds as far as more technically advanced systems.
Yeah, for sure. And, I've been a big fan of your work, and I think the 3D2A community was really fascinating for me because the last time I've ever heard of it was maybe in 2015 or so, when there's the original, I think the Liberator came out in 2013 or so. I could be wrong. But when I first saw that stuff, I thought it was, just some niche projects. And then around maybe a year and a half ago, I got my first culture shock watching a PSR video, my YouTube feed. And I'm like, man, this 3D printed firearms have really advanced a lot. And I want that same community and development style to really mesh in with more technologies, because small arms have been a relevant form of defense for many centuries, but things are changing really fast. Yeah, for sure.
Exactly. Yeah, things are changing very fast, and I think a lot of people aren't realizing that. So to kind of go to the beginning here, what is your overall idea of, at a very high level, what's your overall idea of what you would like to see in the open source do-it-yourself UAV or drone area? Like, what do you think the focus should be as far as capability? What is possible? What might not be possible? And what's just the overall idea you have of where you'd like this to be in some point in the future?
I see. Overall, I think so. The technology's there. We could see that if you go through development forums, if you look through a lot of documentation, all the work is there. It's just no one's really put it in what I would say is a refined package. Like how before we start streaming, we're talking about DJI and how they made this just out of the box, ready to fly product. And all the technology DJI is using is frankly now out there in the open source community, but there's been this weird kind of separation there's the racing drone people who, it's a bare bone frame. It's all about pushing the performance. And there's the more like research and enterprise type people who are flying larger octocopters and things like that. And none of these things were really refined in a way to the point where someone could buy a kit, put it together, and just fly immediately like a DJI drone. And that's kind of the direction I want to see. I want to see more refined hardware and software ecosystems where it's something that most normal people who want this could follow along and build without being too intimidated in. Because frankly, getting into drones was intimidating for me too, because overall it looked way too complicated. I watched a few YouTube tutorials. I was like, there's no way I could learn to configure autopilot and whatnot. I can now, but it did take me a few years, and that's not really the best way to draw in more people.
Absolutely.
Yeah.
Yeah, it's definitely, there's a lot of aspects to it. There's mechanical, software, electronics, hardware. There's a lot of aspects to it to getting the system that works well. So you're right now working on a project. I think we actually had it on the cover picture of this video. It's a project you've been working on for a while. Why don't you tell us a little bit more about that and what the project goals are and kind of what you've had done so far?
So the cover picture is actually a drone I've been working on since around 2019 called Valor. And the goal with Valor initially was, believe it or not, I just wanted an enterprise level drone to play around with. But drones of this kind are, so by enterprise, it means more for commercial, military, law enforcement type use, more for fancier drones. The Usually the starting price for these systems are about $10,000, which is
Insane.
yeah, it's insane. And I started to do more research on DIY drone development, which I frankly didn't really pay attention to because I thought, hey, it's just complicated stuff. You mostly build racing drones and whatnot. But I was surprised to find that there's a ton of just free resources out there and a ton of development for all the pieces you need to actually build an enterprise type platform yourself. And that's what this project kind of became. I wanted to see what to what level could you take open source off the shelf parts and create a system that's comparable to what's on the market. So this is not your typical DIY drone where it's a bare bone carbon frame with a flight controller and everything zip tied together. Valor is supposed to be a refined multi-mission uh, tactical specific platform. So when I first drafted the concept, I had certain requirements that I wanted. One was it has to be quieter, it has to fold, it has to be weather resistant, it has to be modular. And most importantly, and the most challenging part of this is trying to make it future proof because drones like your smartphones, new models come out every few months almost at this point. Drones are kind of similar. I would say every year, 2, 3 big changes come and they keep getting obsolete. And that's just really annoying to see. I want one really good future proof platform, and that's what Valor is supposed to be. And from all the development that goes into a complex system like this comes, well, you gain new skills and capabilities. And that's kind of how I structure my platform, build something advanced and then branch it off and build more subsystems and sub technologies off of it. And that's the overall goal of the project.
Absolutely. So if you wanted to configure Valor for a more of like a surveillance role, let's say,
Yeah.
a medium range, some sort of observation role, what would the more detailed components look like? Like, what would your video system look like? What about issues with jamming or denial of communication between the ground and the drone? What does your sensor system look like? Like, what would that a surveillance based application? So you're not trying to drop anything or do anything complicated. You're just trying to observe a certain area, from a certain distance. What would that configuration look like, and what are some of the issues you can run into, and how could you? Well, we'll get into more of the jamming stuff in a minute, but just kind of what would that particular application look like?
So for that particular application, actually the default configuration in that picture, that's the default configuration for Valor, is for an ISR role, or it's called intelligence, surveillance, reconnaissance. And really the heart of a system like that is your optics package. And this is where there's been a lot of development over the years, from thanks to cell phone cameras. Nowadays in a flat cell phone, you could fit crazy optics in there and much better sensors. And taking advantage of that, the overall system I'm using is so. We were talking about this earlier, but there's analog and digital videos.
Mm-hmm.
Analog videos are they're reliable and they're easy to set up, but uh, they're not secure, and the quality isn't the best. So for a more surveillance role, you typically want to go with a digital system, which is what Valor is using. Which there's quite a lot of digital open source drone image transmission projects out there now, and
That's
without
awesome.
that, this wouldn't have been possible. I'm particularly right now using OpenHD, which is a pretty well developed project where we're using 2 Raspberry Pis and Wi-Fi cards to transmit video over 5.8 or 2.4 gigahertz. And really, the heart of the system is have a camera, have a way to stabilize it. In Valor's case, it's in a pod. We call it the optic pod, and it's stabilized using brushless gimbal motors. And then we beam that video out using Wi-Fi, long range Wi-Fi.
Okay, so that's a clever use of existing equipment. I actually have not thought about that. What about what kind of like range would you get out of? That's of course just the video side, and we'll get into the control side in a second. But what kind of reliable range you expect out of a system like that, and what's the latency like? I guess latency is not that important for an ISR role, a surveillance role, because it just isn't that important because you're trying to see something on the ground. As long as you're within a second or so, it should be perfectly good. But what kind of performance do you get out of that kind of system?
Yeah, sure. So in terms of performance, it depends on a lot of factors. Like one of the testings I actually would do is we take the ground station antenna up out a window in a second-story building, and then drive around with the receiver with the transmitter from the drone end to kind of test the range, see different configurations. To simulate a drone in the air, and then ground station on the ground. And interesting thing is, so line of sight, the record for OpenHD is over 100 kilometers, which is pretty crazy. So
now that's probably with a lot of directional antennas, though.
A lot of directional antennas for sure. But with omnidirectional antennas, practical range is 2-3 miles. But again, it would depend on.
Impressive. I mean, it's
impressive. Yeah.
That's like what analog video does, like analog 2.4 does with basic directional antennas. Yeah, that's impressive.
But of course, that's with it's because the drone's in the air. If you have like tall buildings and whatnot, that's gonna affect your range for sure.
Oh yeah.
And another big thing is I did not account for this until we started doing some testing. Wi-Fi routers in homes, that'll screw up your range too, because I live in the suburbs and all these houses have huge Wi-Fi routers, right? So they're pushing out Wi-Fi signals at 5.8, 2.4, the same frequency range I'm using for the drone, and that can affect video signal too. So there's, that's one challenge with using civilian radio bands, the ISM bands, is so many people are using it. You have interference and all that kind of crap. So that is kind of a challenge.
So what about the control side, as far as a data link? And then, so like back when I used to do it, you'd have the video, which was analog. Then you'd have your RC, like radio control link, which is pretty typical, like pulse width modulation, RC type control. And then separate from that, you'd have like a data link if you wanted to get data back from the flight controller about what the status and position was. But how is that control and data side handled nowadays? So
it's actually roughly the same. There's just new standards to simplify on the hardware side. In Valor's case, because it's trying to replicate more enterprise type control, we're using so you can fly directly off telemetry radios with encoded packets. So in our case, it's 915 megahertz. It's a long range, actually enterprise grade radio. These are pretty popular. It's a RFD 900. I actually have one on my desk. These tiny radios, and again, these can go 100 kilometers easily, radio line of sight. And I think that was without directional antennas too. They work really well. And basically, one would go on the drone connected to the flight controller, and one would be on the ground side connected to a computer, where actually in Valor's case, I'm playing around with USB inputs. So like a gamepad controller could fly the drone, and it would fly over the telemetry link.
Yeah, and of course there's some latency there, but as we talked about a little bit earlier, latency is not that important, in a observation role like this, because you're not trying to do like racing drone stuff or where split second commands are important. Okay, so that makes sense. So you're not even using like a standard RC control. You're doing everything through the data
No.
link, which
Yeah.
I like. I like
Yeah.
that. Because back I always used to use I think it was the Dragon Link, and it's just a 433 megahertz frequency hopping radio, but it still uses conventional methods that you would find with the rest of the RC world. So what about security? So you get as far as signal security, and then signal resilience to jamming and interference. Because with a flight controller system like the EcoTree Vector that I used to use, if you lost, let me fire that up. And then another aspect here, of course, is GPS. But if you lost your data link controlling, and you also lost GPS, the drone would simply automatically land or abort the mission, like in a way that is bad for you. So how do you deal with that? And then of course we'll talk about GPS a little bit, but we'll talk about that next. So what about like resilience, and what are the methods you can use to deal with that? Like, I guess you could loiter the system, or you could have it move away from the interference area so you can regain control, or what are the different options there, and issues involved?
So that's a really hard problem to solve. What's really good though is, for example, Pilot, which is what I primarily play around with. They've done a lot of advancement in inertial based navigation. So they've even successfully demonstrated examples of, if the GPS is completely jammed or denied, it could, just by using its IMU and gyroscope data, it could kind of guess its way back. There's methods like that. And another way is, frankly, very directional antennas on the drone. I mean, that's kind of what the FPV drone community has done for a while. They, especially in the long range FPV community, they would use one omnidirectional and one very directional antenna on the drone and use diversity. Honestly, I'm more of a hardware guy, so I personally like solving jamming and interference problems through hardware. And one of the methods I've been kind of playing around with and toying with is, I've actually designed shielding so the antennas are directionally shielded to only receive signals from the most likely direction the drone would be facing to the operator. There's methods like that. And there's also filtering methods, which I haven't really played around with a lot, but I've seen some people experiment with different filter modules and whatnot.
Okay, yeah. So I've always figured that. So that interesting, the shielding side of thing is interesting, because obviously you have to assume that any enemy forces are going to have the equipment, because it already exists. I mean, it's law enforcement has it. It already exists. Highly directional, relatively powerful jamming equipment on all the popular civilian frequencies, including GPS.
Yeah.
So finding ways to defeat that are going to be absolutely critical.
Yeah, and that's going to be really hard.
Yeah. That's why I'm thinking it's interesting talking about shielding and stuff to actually like completely defeat it. That would be interesting. And obviously, if you're flying at sufficient altitude, that would help as well. Because the proximity between the jamming and then you is going to be there's going to be less disparity there. But also just having something where if your system does lose all of its control signals, including GPS, rather than just landing or doing something flying totally blindly, be able to dead reckon like you were describing there would actually be quite handy. Yep. I mean, if you can even continuing to dead reckon on the mission, you're going to move away from that ground-based jamming system, and then you're going to regain control.
Yep, exactly. And again, though, speaking of iterating on the topic of jamming and whatnot, this is kind of a touchy topic because people have different opinions on it. But this is why you see kind of industry move for visual-based navigation, because the idea is, hey, in some cases, in some environments, like we've seen this a lot. I mean, I'm always up to date on drone development and the war going on over in Ukraine, because you see all these crazy things people are building there. And in some areas where they just have completely frequency right jamming, literally all conventional drone systems just probably can't work.
Yeah.
And that's why there's a whole push for putting cameras on drones, and it's called VSLAM, or visual simultaneous localization and mapping. So basically the drone,
about to ask you about that next.
Yeah.
Okay, yeah. So basically you're looking at a fully autonomous system that navigates itself.
Yeah.
Okay, that's what I was going to ask you about next, and that's where I think the future really is.
Yeah, I agree.
Not so much for observation roles, but for targeting roles, more active roles, a completely passive, AI-driven system that automatically completes its entire mission as if there was a human flying the aircraft.
Yeah.
So I mean, so are you familiar with the concept of slaughter bots? There was a video released a few years back by a professor who's worked with AI a lot. And
the short film. Yeah.
Okay. Yeah. So that concept basically, how practical is something, maybe not that refined, but how practical is, you called it VSLAM, but how practical is fully autonomous navigation using, I guess, ground features, built-in maps and stuff? How practical is that?
Well, you can actually kind of do it off the shelf. So in terms of basic navigation and whatnot, it's very practical. And in fact, Skydio is a good example. The Skydio is a commercial drone company. They've actually managed to bring this technology to consumer level drones, which is pretty cool. It's practical in the sense of basic navigation right now. The big challenge is, so I work with a lot of friends on the software side of things because they know much more, and I have some friends working on VSLAM and whatnot. The biggest challenge is onboard processing. So you only have so much computing power, you can fit on a drone right now. So the best you can do is avoid obstacles and kind of navigate over terrain. But in terms of actually finding single targets and whatnot, the technology is kind of limited right now. You could have, I guess, an example.
It's so hard to believe that computers are so lightweight, compact, and powerful now that it can't be done.
No, it can be done in terms of navigation, but in terms of targeting out specific targets, there's a lot of challenges to that.
Yeah.
So one of the challenges is actually I kind of had a brain fart over there. Computing power on the drone is a problem, but also optics on the drones, at least from anecdotally problems I've been trying to solve, is you can only have so good optics and resolution on board the drone while you're trying to process it at the same time. So that's why smaller drones getting up close in swarms is practical,
I see. Yeah. Now, as far as talking about a problem there, what size are you talking about as far as overall weight, where you have these limitations?
So,
like, are you talking about like small, like very small, like racing size? You're talking about like larger, like
small,
600
like
millimeter type?
size.
Okay. Yeah, I can understand that being challenged. I think going bigger though isn't really a problem.
Yeah, going bigger isn't a problem. In fact, I was literally talking with a good friend of mine on saying we could literally fit like gaming PC hardware on a large fixed wing platform, and you could have just a ton of processing power. And there's now like small, super high resolution cameras. Like you can get them in like, was it like 50 megapixels per sensor? Insane resolution.
Yeah.
You can have multiple cameras, stitch it, and process it on board. That's possible, but I think why I was trying to answer your question was your example on this was it Slaughterbot or whatever. That's gonna be pretty challenging, and
the little tiny guys. But there isn't really a reason for that, and that was a very particular example. Targeting humans. He was trying to make it scary because that was the purpose of that video. He did a good job with it. But as far as let's say a practical application would be, you want to have a system that, and this would probably be a fixed wing system. I'm a big fixed wing fan myself, but maybe a fixed wing with vertical takeoff, just because launching heavy fixed wing drones and then landing them is pretty nerve wracking once you get to a certain weight, just because you probably know, just because of it's easy to screw up landings. And then boom, there goes your airframe. But as if you wanted to navigate fully autonomously from a launching position to a target, photograph the target, and then have it fly back, land, and you can collect the very high resolution images. Is that practical right now without GPS? Like, is current development being done by individuals? Is that like something that's doable, or is the navigation not accurate enough, or still problematic?
Um, I think it is doable because there are some examples of it, but it does so. The examples I've seen is you put in image data from satellites, and then it will compare it and kind of
Mhm.
terrain match. There's examples like that. Yeah,
That's what I've been thinking
yeah,
about. I think that's pretty good for especially like the United States because
yeah, for
the
sure.
satellite data is all available,
Yeah,
and it's normally pretty accurate as far as major features, like
yeah,
most buildings, roads, all that stuff, trees, most of that's there. That I think would be very very useful, especially when it's fully autonomous, because it would be almost impossible to stop, really, because it's
yeah,
small. They're very difficult to detect, especially a fixed wing flying at, if you're flying at 2,000 feet or something. It's basically impossible to detect. Doesn't come up on normal radar. It's basically a bird,
yeah,
and it can't be jammed. You can't do wide area jamming. So that would be very handy if you wanted to do more covert surveillance. So I
yeah,
think that particular application would be super useful, and it's kind of cool that actually might be able to be done with
yeah,
current tech.
for sure. I mean, most of what most of the small drone technologies we see used by the military are now kind of common. Like the technology is all out there, and in some ways, the consumer tech development is much faster and much more ahead. It's just no one's really taking it and implementing it. There are good companies doing it, like I keep mentioning Skydio because I'm a big fan of what they've done, which is they took cell phone chips and then they took cell phone grade cameras and then they integrated VSLAM into small drones, which is just really cool.
It is, yeah. Yeah, the whole software side of thing goes right over my head. Uh, that's why, yeah, that I need a lot more learning there. So we've talked about kind of the surveillance side, where it's more local surveillance, where you contain a continuous radio link, and then there's things you can do to try to avoid interference from intentional or accidental. Try to avoid interference, make a more redundant, not redundant, but more resilient radio link, and then things you can do to save the aircraft once if you do have an issue. We've talked about fully autonomous systems. To get, it's kind of a more high level stuff. To get into more a little bit more nitty gritty, what are some of the specific other applications you think that small autonomous aircraft would be good for, other than just different types of surveillance?
Okay, what they'd be good for?
I mean, as far
Well,
as like what applications you're envisioning in the future, like I've seen you talked a little bit about replacing riflemen, things more like that.
yeah.
What are the more specific applications you're envisioning?
So one of the more specific applications, at least in terms of it's a application that kind of terrifies me, but I think we're kind of headed toward that direction, which is there's always this concept of surgical warfare, and as we shrink down processing power and the technology of drones down, when I was talking about replacing riflemen, which is the traditional concept of riflemen is engaging targets line of sight, with a firearm. Well, small drone with explosives empowered by onboard computing and offline of sight over an obstacle, it could engage the same target. And those are the kind of scary applications that we already know government contractors are developing, but those are kind of the applications that I think we need to pay attention to and talk about.
Yeah. So that's the concern here is, of course, that government operatives are going to be using these
Yeah,
for,
they already
for,
are.
yeah,
Yeah, yeah,
for things that are highly negative to the freedom and to citizens in the U.S. And elsewhere in the world, for that matter.
yeah,
So that's a big concern. But I think on the flip side, the technology kind of intrinsically can be very, very cheap. Like once developed, there's not much to it. It's not like you're trying to build a mortar or something, which explosives are very expensive in
yeah,
large quantities. So it's more of like rather than going with a brute force old fashioned method, artillery or some systems like that, relying on brute force, thousands of pounds of explosives, you're doing something much, much more precision. And once actually developed, the system should be very low cost. And because of that, I think it's perfect for distributed defense purposes once it can all
yeah,
be figured out.
yep,
So, Yeah, so it's kind of got two sides on it there. So I think, yeah, definitely needs to be a much bigger focus.
Yeah.
And
sure.
yeah, 100%. Let's scan through the comments here, see what questions we have, and then we'll jump into the second half of the video or the live stream. All right, let's scan through. You should be able to see comments over on there. StreamYard has added a few new features, and I'm not quite sure. There is a way of I can get you set up so you can respond to comments as well, I believe, but I'm not quite.
I can see the comments.
If you see any there, just let me see if there's a way I can configure it real quick where you can see those as well. Let's see. I'm not quite sure to do that. But yeah, if you see a comment, just scroll through those, bring it up. I'm just scanning through here.
All right. There's so many, so I'm just trying.
Yeah, it always takes a few minutes. I need to figure a way of having like someone look at them in the background and like bring them up on the screen.
Yeah,
because I can highlight them. Let's see. W. Logan says, "What's y'all opinion of the new Trump Scrambler?" I'm going to assume that's a motorcycle. I'm not a huge fan of Trump myself. I don't know. They're like a little not down to nuts and bolts enough. Like they're kind of fancier. I don't know. I haven't looked at this particular one though, so I don't know. They're more like
Harleys, I don't know anything about motorcycles.
Yeah, I don't know that much either. Let's see. Senpai Oreo wants to know why we're speaking Spanish. I assume that's the same as speaking Greek. Let's see. Deary Knows MMA says drones 3D printed. What's the best one out? So I assume he's asking like, what's the best option out there right now? There aren't really that many good options. Like I haven't seen anyone release. Like that's something you're still working on right now.
Yeah, there's like there's quite a lot of 3D printed racing drone frames, which are basically just taking the carbon frame files and just
they're not very innovative. The ones I've seen aren't very. Yeah, I mean, you might as well just have it cut, and they're not taking advantage of 3D printing. I don't think.
Yeah, actually, you sent me a CAD screenshot of your design. That's kind of the direction I think where people should go, and that's the direction I plan to go too as I progress with my projects.
Yeah, I need to work on that more. It really works. My goal was super lightweight, and I think that with a little more, my number one issue with that project was wiring, designing everything in electronics integration. I have to integrating your electronics into the platform where they can get proper cooling. You can get all the proper wires routed neatly. That's the number one challenge. Like just designing the airframe, it's long done. I got to like figure out and how to integrate the battery where it's properly, because that's your heaviest mass aboard the aircraft. You got to figure out how to integrate that. But yeah, I would really like to work on that project more. Okay, let's see. Right here, Bar says there are really no good fully printed drones. There is a boatload of accessories. Yeah, that's what I was talking about. So I actually have a 600 millimeter, which is like a 24 inch. That's just the standard size. It's a 24 inch, not 20. Is it 24? No. I'm wrong here. It's 20 inch, 600 millimeters in inches. I don't know why I suddenly just completely, my mind went blank there for a second. It's a simple math. It's it's 24 inches.
Yeah. 20, around 24 inches.
Yeah. It's a 24 inch between rotors, fully 3D printed frame, which you can print on an Ender or a Prusa. I think it's just there doesn't seem to be like a huge push, like the 3D 2A community, like printing guns is like seems to be very concentrated compared to up until obviously you're working on it now, but it's the 3D printed quadcopter and aircraft community has been a lot more fragmented and just kind of little projects here and there, not really a big focus towards making something a lot better. So I think that needs to change.
Well, it mostly was it's all mostly carbon fiber because it really is a great material, and then it just kind of ended there.
Yeah, carbon fiber tubing. It's just not. It's not, the tubing isn't optimized. I don't know. I think it could be optimized, but just a straight tube is not necessarily completely optimized as far as weight goes.
Yep.
But I mean, it's a good compromise as far as drag and all that. Let's see. Okay, here's an interesting subject we could touch on. DRE knows MMA says, so is it better buy one from DJI or he knows nothing about drone stuff. He wants to know like buying from DJI versus building his own or other options that might be available. So like right now, what options people have available if they want to kind of get involved. I personally would absolutely stay away from DJI, but I'm a little biased. So kind of what are your thoughts on current options that people could kind of start getting their toes in the water, so to speak?
Well, it's tough because right now the market is DJI or super overpriced drone from a Western company without good software support, or even crappier drones with horrible software support. I don't know. It's always tough to recommend people DJI. I want people to stay away from it as much as possible too. But
so what about like the do-it-yourself option as far as people building it themselves? It's definitely a more challenging project.
Yeah,
but
for sure.
It's not that if there was just it's not that horrible. The complicated side is the software and controller side of things. So what options people have right now as far as are there any good online resources or something right now where they can learn about building their own, even if it's on a basic level, no fancy optics or anything, just to get to learn about it a little bit.
If you want to just get to learn about it, the two good resources are look at the small racing drone community. They sell a lot of kits. They're tiny whoops. They're tiny drones. They're relatively easy to build, relatively cheap to build. Great way to get started in learning drones. I have a lot of friends who started that way. And if you want to go to more advanced like GPS stuff, there's a lot of kits. They're really old, but there are a lot of kits like the F450 frame. I bring that up a lot. It's a basically a cheap Phantom 4 frame ESC motor clone. And there's tons of tutorials on how to get a cheap autopilot and configure it. Learn the basics. Yeah,
I mean, personally, that's the route I would pursue right now.
Yeah.
Until there's like better options, just because you'll be priming yourself to get something better. And if you go with DJI right now, like it might be cool for taking pictures and stuff, but I think you're putting yourself into a corner.
Yeah,
there's not gonna be much future there. So I mean, they're fun and all, but I don't think it's going to be a huge amount of future. Like you want to have room for growth, and going with a DIY option is definitely going to do that.
Yeah.
Let's see. Donald R. D. Cisco says, just learned of synchrocopters today. Pretty interesting. I haven't heard of that.
I haven't heard of that either. I'm not up to date on wacky airframes, but I love looking at them.
Yeah, I haven't heard of that either. Let's see. DRE says those jammers like 9K. Yes, but 9K is not that much to government agencies and stuff. So,
and you can make it. There are cheaper ways to build it too.
To build one.
Yeah.
Okay, so Bar again says the biggest shortcoming is getting your hands on good optics and thermals for a low price. So there was a previous comment up here about using image intensifiers and thermal to get like a fully overlaid image and how cool that would be. So like, what is the current options, and like how much have you experimented with using thermals and other more advanced equipment that would give the drones, basically in the optics pod that would give the drone a lot more capability? So like right now, obviously there's just normal fuzzy cameras available, visible light cameras, but what options are there as far as thermals and then doing fusion and stuff?
So for cameras, I played around. I have maybe 4 or 5 thermal cores from China because they've basically reverse engineered FLIR cores, and you can get it's pretty impressive. You can get thermal cores designed to clip on your cell phone, and you can actually modify that to work with drones, which is what I'm playing around with. That's one option. Another option is one I'm exploring, which is a pretty fun project, is firefighting thermal imagers. There's a bunch of surplus on the market, and I have a core, and they just spit out raw analog video. So you can actually plug it into an analog drone transmitter, and it streams very high quality thermal. So,
oh, that's cool.
Yeah, that is cool. They're heavy, but it'll work on a fixed wing.
Yeah. Let's see. Eagle Eye Shooting retrofitted DJI with a spray can, helps him retouch his targets. That would be a good application for a
cool
guide drone right there.
Yeah.
If you don't need nice cameras or anything. Let's see. Yeah, this is Rob Royce says, if I want to get the FPV, should I get the DJI or roll my own? Can I do better with other drones with goggles instead at a reasonable cost? I think we talked about this a little bit.
If he's specifically talking about FPV, like for racing and the first person view stuff, the DJI one is not really a FPV drone in my opinion. It's I think he's talking about the DJI FPV drone. It's basically, how do I say it? Like, it's this weird hybrid of racing drone hardware with camera drone tech in it. It's not going to give you the true FPV experience. You probably have to build your own.
Yeah, I think that's the best, especially if you're not trying to do anything fancy with, for observation purposes. If you just want to fly FPV, building your own is, pretty. Look into racing drones a little bit if you want to pursue that.
Yep.
Let's see. Here's a little off topic, but Big Boy Judge says, hey, Hoffman, I wanted to start editing CAD files for accessories attachments. What program do you recommend I use for editing prints? I mean, really right now, obviously Fusion 360 is popular. You're probably gonna have to pay for it to get fully featured. You probably use Fusion Yukon, right?
Yeah, I do.
Yeah, and you probably used a professional version.
Yeah.
They used to have a better free plan for like hobbies and stuff.
And they start stripping features out.
Exactly. The alternative, which I would consider looking into, is what Chairman Wan uses. It is Solid Edge.
Edge. Yep.
Yeah. So it's similar to SolidWorks, which is what I use. It's different, but it's similar, based in the same kernel. Solid Edge is actually available totally for free with a non-commercial license, and it's like fully featured. So I would look into Solid Edge, the free download, and it's not for commercial purposes, but it's a very powerful program. So I would look into that too. Let's see. Dale Hill says, I thought this would be the usual firearms related content like my new trigger. No, actually, this is a little bit of an off topic stream. Because I think it's a topic I want to get into more. So it's I think it's important. Let's see see any more in here. DRE knows MMA asks, so what I think about the plastic case used in the Army 6.8mm rounds. I had nothing against plastic cases. I think they're great. The problem is they're super expensive right now, and they're not easy to make. It's I've actually back and forth with a company who makes the plastic for some of those rounds, and they have some really interesting 3D printed filaments, what I'd like to get. But right now the problem is just cost and availability to the consumer market. But yeah, I think they're cool. Bar in response to a previous question about what happens when all the drone systems are jammed, and he says it would land slowly. And of course, this is in the case of DJI, which is I think what they do.
Yeah,
but there's a lot of different options.
Land. Yep.
Yeah, which of course could be terrible. That's like not a good option, especially for something in a more critical environment. So, or if you're over a sensitive area, that could be bad. But we discussed this a bit earlier in this stream. There's a lot of options you can pursue as far as continuing the flight using other sensor data to
the best right now is Dead Reckoning.
Just using your gyroscope and accelerometers.
Yeah, but that also has certain problems too.
Think Flight likes your glasses.
Thanks. I love Cavin's videos too. He is probably the best airframe builder out there.
I think he has the largest rubber band powered airplane. Is that him?
Yep.
Okay, yeah, that's
and he also makes
super awesome.
He makes beautiful flying machines. Like when he throws it and flies, it just flies like butter. It's yeah.
He needs to do a rigid airship model.
Yeah.
Let's see. Power filter. Let's see. They keep coming in.
Yep.
Let's see. I'm scanning through here now. Navigates visually. Yep, we discussed that. ADD Venture says, would Dead Reckoning failsafe have the potential of leading people back to your position?
Yes.
That's always an issue, though.
Yeah.
I mean, if you had it set up right, especially with a fixed wing, it would be pretty difficult. But
yeah.
But I mean, that's where you get back to the rifles. It's where you have those.
And also another thing is both radios and the ground stations are just emitting a bunch of RF signatures. So if I just tell people this, that if someone's specifically after you, there's not many options right now.
Well, that's where a fully autonomous system would be useful
for
super high risk applications.
Yep.
Where you need to do observation, but you want it to be as clean as possible. I think that's what I'm kind of most interested in really right now. Well, I mean, there's a bunch of stuff, but I think that would be really interesting. James Huffman says battery tech needs another leap.
For sure.
With quadcopters, yes. With fixed wing, the move from using lithium polymer to lithium ion, I mean, just my little foam flying wing I had with just some little NC63Bs, whatever those, just the standard lithium ion cells, I could fly for like an hour and a half. And with better airframe design and everything, you can push that out a lot. So with quads and multi-rotors, they're very inefficient, and definitely batteries could be better. But with fixed wing, with lithium ion, you can get some very, very good performance with good airframe design. That's why I like fixed wing. But let's see, we've got a bunch of stuff here. Staggy McStabwood says, I miss any super safety discussion. We're just discussing drones tonight. Yes, pretty much. We're just
super safety
drones.
is awesome though.
Yeah, it's a lot of fun. Let's see. Vanguard says that military contractors use a lot of off-the-shelf hobby parts. Honestly, Pixhawk is probably the best for an autonomous system, but does require GPS. I mean, but you could connect. Yeah, I mean that's true. Yeah, but I mean you could do things with your inertial measurement system with Pixhawk. I mean, I would imagine, right? I mean, I don't know if there's. It's all open source, so you should be able to do that.
I mean, I use a lot of Pixhawks too. You don't have to have GPS, but basically without GPS, a lot of its functions, you can't really use a lot of its functions. And there are a lot of drones by defense contractors that do use Pixhawk based flight controllers, and now the newer Cube Pilot, So yes.
Yep. Let's see. Corn Pop Wonderwolf says, what would be the best countermeasures to that? I assume he's referring to slaughter bots, maybe. I'm not sure exactly what that was in reference to, but thermal mount on an auto shotgun with full choke loaded with heaviest number shot. I don't know. I mean, I think if that's a threat, I think more passive, like wire cages and stuff, would be better actually.
Yeah.
And then find the source and then focus on the source.
Yeah, you have to focus on the source. In my opinion, there's way too much emphasis from counter drone technologies on destroying the individual drones. That's important, but you should prevent that in a lot of ways. Like you should detect a source and take that out before it causes more troubles. It's a hard problem, and it needs a lot of layered defenses. You need one system to fall back to the other, and the other to really defend against a swarm of slaughter-bot type, futures.
Yeah. Absolutely. Let's see. Net gun on it. Here's Sport Brand says, any thought on toroidal propellers for boosted efficiency and reduced noise signature?
I'm gonna plug Kevin again from Think Flight and Holbrook Aerospace. with their work together. They made an excellent video describing a much better answer than I can give. But basically, unless they're like incredibly heavily optimized for your specific application, just go with normal props. It's easier.
Yeah. Mike Bergman says 3D printed drones are terrible. They aren't strong enough to get clean black box logs. Carbon fiber is the way to go. So I would disagree, but I'm not sure what a black box log is in this case. I mean, I know what that references into like commercial aircraft, but in the case of a drone, if it crashes, generally speaking, it's mission over. You don't care anymore.
Well, the black box logs are basically the IMU gyroscope and other data on the sensors and the flight controller. It's a function where you can log it on an SD card.
Mm-hmm.
So you can look back and kind of do didactics on your drones, like kind of solve problems like, hey, you see more vibrations on this phase of flight. Maybe you need to tweak this PID setting or things like that. And it's also when you crash the drone, you can kind of diagnose what happened. That's what he's referring to.
So
but
in this case,
yeah, go ahead.
How would carbon fiber versus a printed frame, which actually can be carbon fiber as well, but how would that, what's the, I'm not quite sure what the point here is. So
what he's probably saying is, if you have a crappy flexible frame, your data will just be crap because you just have all these internal vibrations.
Oh yeah.
That's what he's talking about.
Okay, but that's a design problem.
That's a design problem.
That's not that's a design problem.
It's because all the 3D printed frames are just literally the carbon fiber frame files extruded up. So I mean, that's not how. Yeah,
it would be like me trying to design an AR lower like aluminum lowers are designed.
Yeah, exactly.
It would fail pretty quick. Okay, that makes sense.
Yeah.
I think 3D printing the frames has lots and lots of practical potential. Let's see.
Material is a big factor too, and that's why I can't thank you enough for your PA6 and the carbon fiber PA resources, because that helped me a lot.
Yeah, along the same. So my issue with PA6 carbon fiber is after absorbing moisture, especially here. I'm in Tennessee, so it's super humid. This time of year, and I've been having it just gets flexible to the point where it still functions, but it's more than I would like. So I've been experimenting recently with the Bamboo Labs carbon fiber PET. So generally speaking, I would always stay away from PETG, even PCTG, because they have a lot of issues with impact. But the Bamboo PET carbon fiber, they made some claims about it being impact resistant. I bought a roll, did some impact testing, and it actually has performed really well. It's not nearly as heteroscopic as nylon, stays stiff, and I'm right now printing a bunch of guns with it. I'm only doing a bunch of testing with it to see how it holds up in the real world. But I would very much look into their PET carbon fiber, especially for airframes. I think that unfortunately you can't use a tiny nozzle with it because it'll clog. That's why the PA12 carbon fiber from Polymaker is nice, but that's a different, has its own issues. But the PET carbon fiber from Bamboo Lab, I had not been talking about it too much because I don't want to promote something that might turn out to be bad later. But for everyone watching, check this stuff out. I think it's very, very interesting. So
okay, I might explore it because carbon infused filaments is something I never explored until I started actually watching your videos, and I was like, this is a good because just the amount of stiffness it adds. I honestly think that so long it's dry, if you print a flat traditional frame with PA6 CF, it actually might work so long it's dry.
It's really awesome when it's dry. That's the PA12 carbon fiber stays stiff because it doesn't absorb nearly as much moisture. The issue it has is it has an issue with creep. You have to anneal it because before annealing it has terrible creep. Once it's annealed, it shrinks significantly, which has to be compensated for. All very doable, but it still has some amount of creep. And if you have screws going through it, that are tightened down, they will loosen up over time. And I just have not found a way around that, which is unfortunate. So the PET carbon fiber is looking good, but the PA12 has such a small amount of carbon in it because it doesn't need carbon to stay stiff because the PA12 doesn't absorb water. You can print it on a 1/4 millimeter nozzle, which means you can print really thin, lightweight walls, and you can make some very strong, super lightweight shell structures, which is cool for airframes. Let's see. We're getting near the bottom here. Let's see. So security. Oh, here's an interesting question from GF. What about autopilot for ground-based drones? So, vehicles or little tracked vehicles or something to navigate on the ground. I would think that obviously you would. What are your thoughts on that as far as non-aerial based equipment?
I think there's a lot of advancements in that. Ardra rover, it's a branch up of Ardra pilot for rovers. That augmented with ROS or robot operating system, you can do all kinds of things. And ground-based drones is something that I want to explore later because there's so much more flexibility because it could be heavy, it could have a lot more payload, and of course its capabilities are kind of limited. I don't see ground-based drones being as useful as flying drones overall, but in certain cases, yeah, it's a cool thing. And there's good autopilot development for it.
Yeah, I think it's a lot more challenging in some ways actually because of ground-based obstacles compared to the air.
Yeah, that's true. That's what I mean by
open.
Limited. It can't, like, for example, a big issue is staircases. You've seen some with tracks that go up with staircases and whatnot, but it's just there's not many places rovers can actually go unless you design it well. Yeah,
exactly. So yeah, that's why I think aircraft is the path that should be pursued. Corn Pop Wonderwolf says I think small fixed wing drones would be better than multi-rotors for Overwatch, much longer endurance. Sadly, that's not much pre-made stuff in the civilian market in that category. I actually agree. I think fixed wing stuff is better for a lot of applications because it's so much more efficient. You have much higher endurance, for the payload, faster, and for observation purposes at higher altitudes, not being able to hover is not a big issue.
Yeah.
So I agree. Fixed wing
too.
And fixed wing building airframes is a lot of fun. So there are options there, but I would like to see more focus on fixed wing. People get really into the quadcopters and drones, but fixed wing is a lot of applications.
And just to iterate on what he said, though, there are a lot of civilian options. They're just more catering to the RC community, so more for flying for fun. There are like enterprise fixed wing platforms for bigger cameras and whatnot, but they're too expensive. So yeah, there'll be more developments there, and I am focused on that.
Yep, that's good. Let's see. Carbon fiber wrap. Well, these keep coming in. Like there's some. Let's see. Got some stuff in here.
Oh, we have Vaughn from Vaughnshire Farms. He's running the PVS 69 project.
Oh, Vaughn Sheriff?
Yeah.
Oh, I don't see him in here. Where is he? Glad to have you in the chat.
I just saw him he's on the latest chat, yeah. He's doing really cool stuff too, and I talk with him a lot on
Yeah, and just call me Kako says Kako says bamboo PAHT carbon fiber has been really great for him as well. I have actually bought a roll of this stuff. I've printed some stuff with it. It appears to be a good filament. I'm still working on getting everything together for my big nylon test. What I want to know is how much does it creep? They don't talk about that. I suspect that it has some issues with creep. Because it appears to me that it has PA12 in it, trying to reduce the moisture absorption and boost the stiffness. So I'm going to suspect there's some creep issues there. However, it has a higher carbon content, and that could help a lot. So I'm definitely interested in the PAHT carbon fiber, as well as actually coax. Coax is very stiff and very low creep. However, it has a really poor surface finish, tends to need to be printed on like a 0.5 or 0.6 noggle to prevent clogs. So it's kind of a trade-off, but the coax glass fiber nylon is also a good option for really solid parts. Not so much airframes because it tends to be heavier because of the larger nozzles. It's hard to make fine structures. We've got lots of questions here. Let's see. Okay, so there's Von Sheriff. Fixed wing stuff. Cool. Yeah. Did I
Yeah,
read correctly?
there's a lot of cool drone devs in the server, and I'm in there too.
Okay, so it's almost already 8 o'clock. I'm kind of going over. These questions always absorb so much time.
Yeah.
Okay, here is a topic I wanted to get into. Just a couple more topics I want to get into. So we might as well do that and then try to scan through here for some more questions possibly. Remote IDs, what the FAA is trying to do to drones plus fixed wing pilots like the ATF with all their overreach. Everyone please look up remote ID if you have any interest in this stuff. So let's talk about a little bit of the regulation. Back when I was involved in doing this, it was before they really did all the regulation stuff.
Yeah.
Free men don't ask, obviously. But what is kind of your thoughts on the regulation side of thing, and how much has that caused issues?
It's literally affected the whole industry, and it kind of bottlenecked industry too. I mean, up until 2016, you could do anything with drones, and then now there's the September of this year, all drones that are flying need to have above 250 grams have to have remote ID on board and active. So I don't think many people know this, but I've actually originally had interest in growing a business selling drones, and then that got thwarted from remote ID because unless the fully made product you're selling is compliant with remote ID after 2022 and forward, you can't legally sell it in the U.S. market. It's pretty insane. So for people who don't know what remote ID is, it's basically a transponder that you have to have on your drone about 250 grams, mandated by the FAA. That'll transmit the drone's location and the location it took off just publicly, so anyone on their phone can pick it up and identify the drone and where it took off from. And that is going to be mandated from September of this year forward. And the problem with this is, well, first of all, if let's say you're a criminal trying to affect operations of an airport, do you think you would put a remote ID transponder on your drone?
No. It's the same thing with like firearms regulation.
Yeah,
if you want to cause if you want to cause disruptions, it's not at all hard to do. What they're trying to do, what their goal here, I don't know what the individual regulators and goal is, but what I see as an overall trend here is that small, low-cost, unmanned aircraft pose a significant threat to the power structure because it could be a very powerful tool that would be accessible to a lot of people, not just people in government or people with huge budgets, like militaries. So I think they don't like that, and they're just trying to stifle innovation in the industry, basically, by adding all these requirements on a high level. I think that's basically what it comes down to, because from a safety standpoint, drones have not been an issue. It's as simple. There's been a lot of hysteria in the past, causing aircraft problems. Birds are a lot bigger issue than drones. I mean, statistically, that's the fact of the matter.
Well, also there's more there's a deeper history to remote ID, and the reason why so many members of the drone community has beef with Amazon is Amazon also was involved in pushing this. There was a lot of corporations pushing this with lobbyists. The reason why is to get your delivery drone infrastructure. The FAA said, hey, we need to reach a compromise where we can keep track and control the airspace for unmanned traffic. And a compromise was remote ID, which is not only applying to commercial operators, but to private hobbyists, which is I don't understand. And it's not going to stop anything because bad people are going to ignore it.
Yeah, exactly. And it's pretty hard to enforce.
It's hard to enforce. And not only that, it's going to pose more problems because already, if you saw the cybersecurity community work, they've already developed spoofers that can basically, on the remote ID system, summon 16, 18 drones and have to fly in random directions. There's no drones out there. It's just spoofing the system. And imagine now that all airports will have remote ID, surveillance systems. You could just spoof it with now a phone app. Some people have developed that too, because it's over Wi-Fi and Bluetooth, which is really stupid.
Yeah,
not thought through.
Yeah, that's. I mean, which obviously, that makes it so that you could shut a whole airport down if you wanted to, just by spoofing that there's drones flying.
Yeah, you don't
around.
even need a drone. Yeah.
You could do it without even needing a drone. That's an excellent point. And I know. I've seen some of the stuff in England where they've shut airports down because of supposed drone sightings.
They never spotted them.
There
on a
actually,
camera. Yeah,
there was no UAV.
Yeah.
So it's, I think that components are still available to build your own, and that's what's important.
Yep, that's true.
Let's see, right in here, there has been discussions, stabbing McStabwood. There's been some discussions in the comment section here about stiffness and how important is stiffness with materials. It completely depends what you're doing, but just because something is stiffer does not mean it's more fragile. Look at mild steel. Mild steel is a lot stiffer than a part 3D printed in PLA Plus, for an example. It's also a lot stronger and more durable. It's because it's simply a stronger material. So just because it's stiffer doesn't mean it's more brittle. So polycarbonate, for an example, polycarbonate is pretty fragile, actually. And I've no longer used polycarbonate for anything except, really for anything, maybe very niche purposes where I absolutely cannot tolerate any creep. But polycarbonate's a good example of a stiff material that is also brittle. But just because it's stiff doesn't mean that it's necessarily fragile or brittle. This new PET carbon fiber I've been testing is pretty stiff, but also is strong enough where it has good toughness as well. So that's a very simple kind of analogy, but it's not just a simple trade-off. So stiffness really is better in most applications where you don't need flex. More stiff is always better as long as there isn't other issues with becoming fragile. And especially when it comes to airframes and stuff, stiffness is pretty important.
Everything.
Yeah, stiffness is pretty important. Okay, so I think we've covered all the basic. There's so much more to cover here. We've just kind of covered getting people to understand that the situation and kind of what we're discussing. We've had like 125 people on YouTube and 15 on Odyssey. So that's pretty good. This discussion's on Odyssey about Wi-Fi. For a spotted drone. Wall issues. Thermal camouflage. Yeah, so just to close things off, what are your thoughts on like defense turrets? I know I did a post yesterday on Twitter about that, but it's something I've thought about for a while now. So obviously it's not drone related, but like a fixed defense turret or maybe a ground-based defense turret on a moving platform or something, but more like fully autonomous AI driven defense systems, like automated defense systems that could detect, obviously with airsoft, that could, detect intruders and all of that. Like, is that something you've ever thought about, or what? You have any thoughts on that?
I think they haven't been explored enough, and they have a lot of potential. One thing I even thought of was you could have paintball based defense turrets with pepper balls. Like, that would be fun. A fun security system. And you could pack in quite a lot of processing power on a ground based turret, and I could see a lot of uses for it.
Cool. Von Sheriff says some guy who joined the Discord posted videos of his. I assume in reference to a defense turret. That's pretty cool. So here we go. Okay. So Owen Miner says, is there a high level feature list in project to contribute to? So this is kind of how I wanted to sort of finish off the discussion. What is your current game plan as far as projects we've already discussed some of the projects you're focusing on, but as far as what your release packages, like I design, firearms frames and stuff. I release like with the Orca, the Super Safety, I release like all the files, documentation, and like needed resources for someone to recreate that project. So what's kind of your image of what you want that to look like with a UAV? Like, what would that data look like?
So what that data would look like is, so I've been thinking about that a lot. So I want to go in two approaches, which is design a drone system that's more cheaper than Valor and similar in capabilities and enough for the average person, and something that's intuitive like a DJI system and something you could build at home. I want to design something like that, release the CAD files along with detailed tutorials on how to assemble it. That's one direction, and that's to satisfy most of the audience. Most people who want a drone but don't want a DJI
and that's
system.
more airframe orientated. I guess.
Yeah.
The big challenge for me, of course, is the control side. So how would you integrate that in there as well?
So integrating that is, I'm pretty confident that with by taking generic parts that are common for drones, and then taking like I've been looking at iNav a lot, because iNav is kind of like they say, like the baby version of ArduPilot, something like easy to get started with, but it gives you the GPS functions and basic waypoints and things like that. I want to make something comprehensive enough that someone could just watch the video and kind of follow through. But there definitely needs to be more work in the software side. Ideally, I mean, I'm not doing a lot of software work right now. It's all hardware and electronics. But ideally, it would be like you're talking about the Eagle Tree system. Um, I hope I can get more people on board on my team to develop something like that. But right now, it's get the hardware out, so the more kind of techie people can get started in this. And depending on community feedback, I think that's what will really consolidate the direction I plan to go. But it would be CAD files, schematics, photo by photo tutorial videos, all of that. I want to make kind of a complete comprehensive package on how to build this, and then additionally give resources so people who want to develop their own branched off of this can.
Yeah, I so along as far as like the electronics hardware side, I think there would be huge potential for a kind of more dedicated, properly designed flight controller with a good software ecosystem that you could buy like in a kit. That kind of thing, I think, would have a huge demand, because the electronic side of thing is definitely the most complicated aspect of building a UAV, and having that worked out for people would be, I think, remove the biggest obstacle to people building their own accessible platforms.
Yeah.
So that's it's going to be really interesting. We have a comment here. There's been some discussions about my thoughts on EDM. We have Zurad in here from Rack Robotics commenting on 3D printing plastic is cool, but EDM aluminum titanium is going to change the game. So Rack Robotics, they're a startup who is doing basically home-based EDM. Have you seen some of their stuff?
Yeah, I've actually been talking with John from there. He's really cool. Very helpful guy. Yeah.
They have. I backed the Kickstarter campaign. I should be getting my my power supply in here, the EDM power core, I think they call it, pretty soon. So I'm super excited about learning about EDM and doing some EDM stuff. But I think, EDM, and especially like wire EDM, like home-based wire EDM, I think it's going to be possible. I think they're working towards that, and it's going to be super cool, because EDM is the kind of thing which, if done right, can be very accessible but extremely capable. So I am all about EDM. Yeah, I think it's going to be really cool. So definitely check out Rack Robotics.
I've become a even bigger. I've become even more interested in EDM after I got a CNC mill. I mean, CNC milling metal parts. I'm like, yeah, it's just a pain. It's slow, and your finishes are hard to perfect. Just wire EDM. I can see why so many big companies are going with it. It's faster too, probably in the long run.
Yeah, it's and it's just the hardware. I did see some of the parts you're machining. It's kind of cool, especially for like a wood router. Almost, you're doing a little bit.
It's almost a wood router, and I'm kind of modifying it.
But I mean, the big thing with EDM is you don't have nearly as high tooling forces, so you can like have a much cheaper, lower cost motion system to run it. So it's it's pretty cool. It's pretty cool. Let's see, we've got quite a bit of stuff in here. Think Flight is here. It says cell-tuned autopilots for a given airframe in addition to all the physical parts. If they want to dive deeper later, they can.
That's true. Yeah, that's actually a good idea. I just already pre-configure it in a given airframe, and it should work out of the box. And then if they want to kind of play around with it more, they have all the hardware. That's a good point. Yeah.
It's and another thing is wiring harnesses. Just throwing it out there. That's something that seems so simple, but
it's
wiring harnesses don't want to underestimate the thought that has to go into doing that properly. So power distribution, all of that kind of stuff. If that could be done in a kit, companies could sell that. If it was all open source, companies could sell that. Who have people who are experienced in doing that can assemble, build them, all of that. They can make money doing that as well. But that would make it a lot easier for people like me to get involved without having to get too into all the skills needed to do all those things.
Yeah.
Yeah, I think that there's a lot of potential there as well.
Wiring is such a pain that actually, for most of my drone projects, I end up actually drawing the wires in CAD. I have to go through that pain just to plan everything out.
Mm-hmm. Yeah, it's wiring. I mean, especially on multi-rotors, because there's a lot of it and you have very little space. Fixed wing is a little easier because you tend to have more room and depends what you're doing. But yeah, on multi-rotors, wiring is almost like on helicopters. It's a lot to it. Yeah, so Zerad's in here. 2D objects are the majority. Right now, their current EDM setup is not wire EDM. It's kind of like a plunger based EDM.
It's like a copper electrode, right? I think.
Yeah, exactly. Yeah. So and obviously that erodes, so it's got limitations, but I mean it's what they're working on.
It's a good start though.
Exactly.
Yeah.
And the power supply is can be used for anything really. And that power supply for EDM is actually, there's been projects in the past where people have built them, but it's pretty problematic. So it's pretty cool if they did that.
But I agree that 2D is the future. After milling 2D parts, I'm like, it's faster, it's cheaper, it's scalable.
Yeah, as far as doing stuff, I mean, you can look at Glock, what they did with their stamping and stuff. Trying to keep things simple is good. Of course, unless you're doing 3D printing, and then you should take full advantage of that third axis. All right, so I think I've gone through most of these questions here. I'm sure there's going to be more. Why don't we can do an outro? We've been going hour and 17 minutes now, so a little bit over the hour, but that's okay. It's been super interesting. Let people know where they can find you, and why don't you give us like a kind of maybe a quick summary of where you think they should go for the audience to kind of bring them all up to speed.
Okay, so you can follow me on Twitter at Canine Defense Tech, and you subscribe to my YouTube channel because there'll be a lot more educational content coming along the way. I'm mostly on Twitter. If if any of your questions, there were way too many questions today, but if your question wasn't answered, you can always hit me up on Twitter. I try to reply to every question. In terms of the general direction I want to go is really the community will really shift the direction I think I'll be taking things. I want to, there's always the ideal direction I want to go with drone technology that's in my mind. But once you have feedback from other people, you realize that you can't always see the full picture. So I'll be slowly releasing more and more resources related to drones, helping people get started on their own drone projects, and hopefully build a development ecosystem that we can take to the next level. So, and
absolutely,
yeah,
that's pretty cool. So yeah, I would definitely recommend, if you guys are on Twitter or even here on YouTube, check out Yukon's page, Canine Defense Tech. Is it?
Yep.
Canine Defense Tech. And yeah, I mean, he posts a lot of interesting, thought-provoking stuff. So that's why I just spotted you on Twitter a while back and kind of liked what I saw. And I've just been kind of seeing him like, I got to get this guy in a live stream to discuss this in more detail. And we've only kind of touched the basics here. We haven't got anything really nitty gritty or anything, but hopefully it'll get people more familiar with the subject. All right. Yep. So I hope everybody enjoyed the stream. I'll finish off by throwing this comment from Zerad up here. He calls their current system simulated wire or rod EDM. So they just have a single copper electrode cutting stuff out. But yeah, definitely he's working on wire or interested in doing a wire setup. And I definitely look forward to an accessible wire EDM. That is going to be.
Then you can start cutting really precise stuff.
Super awesome. Yeah, super awesome stuff. All right. Thanks everybody for watching. Be sure to check out Yukon's stuff. Be sure to be thinking more about things other than just firearms. There's a lot of stuff we didn't cover today. We didn't cover heads-up displays. We didn't cover. I want to talk about that, but we'll have to save that for another one. It's another subject. We haven't covered a lot of augmented reality stuff. There's so much stuff here that is potentially extremely capable equipment that can really magnify the capability of civilians and civilian defense force type stuff. So there's a lot more out there than just basic firearms. So
Yeah.
be thinking about that, guys. Look into it. And until next time, thanks so much for watching.